Okay, so can you guys hear me, beta? I see the students are. Can you guys hear me, my dear? Okay, I think now the voice is fine. Okay, guys. So again, welcome to the Gate Academy. Very nice, Satyam. Thank you, Gayatri. So welcome to the Gate Academy, my dear. My name is Umashankar Tripathi, and today's session, we are going to talk about the important concepts of fluid statics. So I see the live students were waiting for me. So some technical thing have happened. So that's why, first of all, for the live students who have been waiting here for a while, thank you very much for waiting for us. And due to some technical issue, the session got delayed by a few minutes. So we are going to cope it up. Okay, so guys, my name is Umashankar Tripathi, and currently I'm a research scholar, what you call a PhD scholar at IIT Roorkee. At IIT Roorkee. Before this, I have completed my master's in technology from IIT Roorkee itself. And as far as my teaching career is concerned, I am into this profession from last 9+ years. Okay, and about my GATE examination, I have qualified GATE twice. First in GATE 2014, in which I had 66 marks and All India rank of 916, and in GATE 15 as well, in which I had 77 marks with All India rank 643. Okay, so this is a brief introduction about me. Now, see, the GATE is very close to us. Okay, the GATE is very close to us. I think somewhere near already October is over, so November, December, January. We have mostly 3 months for preparation. Now, we very well aware of this fact that the fluid mechanics is a very, very important subject for both mechanical and civil engineering aspirants. Okay, so I hope you guys having your preparation is going in the right direction till yet. Now, to brush up your concepts, we are having this session in which we are going to particularly talk about the fluid statics concepts. Okay, guys. So, in today's session, what we are going to do, we are going to have a quick recap. We are going to have a quick recap on the important topics of the fluid statics. So, guys, please tell me, those who are live here, what do you feel are the most important topic in fluid statics? So, as per the quantum of questions that is being asked in the previous year GATE paper, I think that Newton's law of viscosity is very, very important to start with. Do you agree to it or not? If you see GATE previous year questions, guys, we are seeing a lot many questions on Newton law of viscosity. So, those who are live can tell me that what is Newton law of viscosity, so we can have an interaction here. All right. Newton's law of viscosity. So, what is Newton law of viscosity? So, see, in this, when we are so much close to the GATE examination, and we are very well aware of this fact that GATE is a numerical set of paper. It is a kind of numerical paper. Okay, so we are very quickly brushing the concept because, see, quick revisions are also very, very important for getting success in this examination. So I am not interested in the definition of Newton's law of viscosity. We are going to converge our concept in how to solve the question. So the first thing in Newton's law of viscosity, what does the formula say? Formula says that tau is equal to mu du by dy. And what is this mu, my dear? What is this mu? So I hope we understand this mu is what? It is the coefficient of dynamic viscosity, right, my dear? It is the coefficient of dynamic viscosity. And my dear, remember, very much care shall be taken of the units, right? Because many students make the silly mistakes. Many students make the silly mistakes in solving the question. They know all the concept, everything they know. Okay, everything they know, but they make silly mistakes in the unit things. Okay, So coefficient of dynamic viscosity, what is the unit of it? So if we somewhat forget the unit also, we can have it found very quickly with the basic formula. So what is the unit of stress? So we very well know, sir, the unit of stress is Newton per meter square or Pascal. This du says the change of velocity. To change the, is it represents the change of velocity. So change of velocity unit is meter per second, right? And this dy, it is showing some distance as we know it, right? So this dy is showing some distance, so it is also in meter, my dear. Okay, so from here we can develop the unit of this particular entity, and it will come out to be Newton second per meter square, right, my dear? Okay, very good, Satyam. Okay, no, Newton second per meter, you are saying it is Newton second per meter square, or we shall say Pascal second. Okay, we shall say Pascal second. Now, sometimes what they do, they may give you the coefficient of dynamic viscosity in poise. Okay, so if they are giving you in poise, do remember to convert it into the SI unit, that is Pascal second, because mostly we are interested in finding also what is the use of this Newton law of viscosity and how it is playing some role, how it is playing some role in our analysis, how it is playing some role in our analysis, or where it is actually being used. Okay, where it is actually being used. Any comment on this? Any student can respond. Please tell me, where do we use it? What is the use of Newton law of viscosity? So the basic use of the Newton law of viscosity is that we are engineers. Okay, so we are very much interested in finding that what we are losing. Yes, Gautam, it is being used in the bearings. Right, Pranjali. Very good, beta. It is being used in the bearings. Right. Lubrication, very well. Okay, so we, I think, are aware of this fact that there is lubrication is a very important part. Even in our body, there is lot of lubrication happening between our bones and everywhere, right? So, so many lubrication is a very important factor of both mechanical and civil engineering. So, see, what is the Newton law of viscosity? What Newton law of viscosity says that whenever we have a real fluid, even anything, any real fluid, maybe a lubricant or water or something, and when we have another surface which is at some different velocity compared to this surface, so what we can assume? We can assume this other surface at stagnant condition, or it is fixed. Okay, though do not get confused on in this. Do not get confused in this. We can have it, the other surface can be fixed, or the other surface can be at some different velocity to that of the velocity of the moving surface, right? Moving surface. Now please remember this. So we have this surface which is moving at some velocity, let's suppose v. Okay, and this is at velocity 0. This is at velocity 0. Now to understand this formula, the formula says tau is equal to mu du by dy, right? Mu du by dy. So to finding the shear stress and what to multiply with the stress to make it a force. So obviously, sir, we should multiply it with area. Now remember, guys, that we shall multiply it with surface area. We shall multiply it with surface area, right? Now, if it is a rotating body, now remember this, guys, whenever something is moving in a linear pattern, then we have this force, and whenever something is moving in the rotational manner, we have the torque, right? So we may have to find the torque as well. So when we have to find the torque, we shall multiply this force with the radius of what? Radius of the rotating body, maybe the shaft. Okay, and with this torque or the force, we can obviously find the power, which is T into omega, or force into velocity, or force into velocity. Both represents the power, right? And what is the unit of this torque? The unit of this torque is Newton meter. And what is the unit of this power? It is Newton meter per second. Don't get confused. Both ways you will be finding the same unit. Okay, which you sometimes also say as watt. Okay, now if you see a Newton law of viscosity question, we somewhat may require to move from the shear stress to the force, maybe then to the torque, or maybe to the power. So this is the kind of question that we see in this particular topic. This is the one way. Other way around is if we are moving in the backward direction, that we may move from power to the torque, then torque to the force, then force to the shear stress. So either way a question can be framed. Now to solve the question, it is of utmost important that we identify this. Okay, what to identify? Okay, so to make or to find the shear stress, what shall be happening here? Okay, so we must see that, okay, this is the surface. And where is the surface? Is this the surface we are talking about? No, my dear, this is not the surface we are talking about. We are talking about the surface which is inside the plane of the screen as you see it. Okay, which is inside the plane of the screen when you see it. So this is the surface we are talking about, my dear. This is the surface we are interested in, which is parallel to the other surface. So what surface we are talking about here, beta? We are talking about of this surface. And we must take care while solving for the force that if required, we shall multiply it with the surface area. I hope you guys will remember this thing. Now, to find the shear stress or to use this formula, we must be using this expression. So any question of Newton law of viscosity, so how to identify in the examination whether the question is asked in the domain of Newton's law of viscosity. So my dear, please understand this. So whenever you see a question in which you have a liquid, you have a velocity difference. So what we should have? We should have a fluid. Okay, we should have a gap. Okay, we should have a gap, and we should have a differential velocity, means difference of velocity. So if all these things are there, you may recognize that, sir, this is the question of Newton law of viscosity. Now, obviously, to solve it, you require what you require here. What are you requiring here? So let's suppose the velocity of this surface is v. Okay, and here velocity is 0. Okay, so what we can say? So what is in general? What do you mean by du? So du is basically the velocity difference of 2 points. Okay, so if I say this is the point 2, if I say this is the point 1, so we can say u2 minus u1. Okay. Similarly, what is this dy? Dy represents the difference of 2 points in terms of distance when seen from some reference. So if this is y, this is going to be y2 minus y1. This is going to be y2 minus y1. So what is this u2? So we can say, sir, this u2 is nothing but v. And v minus 0, we need not to write anything here also. And this dy is y2 minus y1. So basically, it is this gap here. It is the gap here that we can see. So this is going to be h. So tau is going to be mu v upon h. Now, with the use of this formula, obviously, you can find the shear stress. Will you be able to find the shear stress or not? Now, to consolidate or summarize the thing, so we have a surface. Okay, we have a surface which is not moving. We have a plate of somewhat moving at some velocity. So what we require to find the shear stress? We require a dynamic coefficient of viscosity. We require a velocity v, and we require a gap here that is h. So these are the sufficient data. Now see, you are seeing an equation on the screen. Now, if anyone want to ask you something out of this equation, you see 4 variables are there, right? Simple logic, four variables are there. So if they want you to calculate something, they must have been giving you the other data, or they must have made this arrangement. They must have made this arrangement for for you to find out the remaining data, whatever is required to find some other quantity or entity. Do you agree to me on this or not? I hope you guys agree to me on this. Okay. Now, if we have a velocity, if we have a dynamic coefficient of viscosity, and if we have a gap between two surfaces, will we be able to find the shear stress? Right, so we will be able to do it. Now, the other way around is, what we can do. The other way around is what we can do. So, if you are given with the power, you may find the torque from here, then you may find the force from here, or if it is a linear system, you may directly find the force from here, and now from the force you can find the shear stress. Okay, sometimes they frame the question like this also. So from if you find the shear stress, you put it in this formula, and the other variable is required to be found in the question. I hope you will be able to find it as well. Now, where the mistake happens, a mistake happens in the area. Now, again, I am making you to understand this. So, the shear stress that we are having here, if you want to find the force, you must multiply it with the surface area. Remember this, you must multiply it with the surface area. Will you be able to do it or not? So, shall we try a question, beta? Shall we try a question? Now, please tell me if all this thing is clear or not. Please answer me, beta. Please answer me. What do you say? What do you say? I am looking for your answers, beta, in the YouTube chat section. Will you be able to do it, beta? Please tell me, beta. Very nice, my dear. Very nice, my dear. Okay, very well. Okay, so I want you to try this question, beta. Just one moment. Okay, here we go. Here we go. So, guys, while you are solving this question, please read the question carefully. So, where is the figure? There is no need of figure in this. Okay, I'll make the figure if you want, although no need of figure. So, calculate the dynamic viscosity of an oil which is used for lubrication between a square plate of size 1.8 into zero point 0.8 and an inclined plane with an angle of inclination as 30 degrees. Okay, the weight of the square plate is 300 newton, and it slides down the inclined plane with a uniform velocity of zero point 0.3 meter per second. The thickness of the oil film is 1.5. So I'm not going to make the figure out of it. You conceptualize the figure and try to solve it. Please go for it, beta. Let's see if we can do it or not. Let's see if we can do it or not. Please go ahead. I'm very sure you guys can do it. And meanwhile, please do not forget to subscribe the channel and share the video with your friends also. Right? I'm very sure that we can do it. Waiting for your answers, beta. In the live chat section, I am waiting for your answers, guys. So how to make the figure of it? I hope we guys are trying it. So we have what is saying that's the calculate the dynamic viscosity of an oil which is used for lubrication between a square plate of size zero point 0.8 and 0.8 meter. Okay, so we have some square plate here. Okay, so this square represents the surface here, beta. This square is representing the surface here. Okay, Pranjali have given some answer to me and it is correct. Very good, beta. It is correct. Very nice. So we have this surface, beta, and there is obviously some liquid. So you must have seen these kind of arrangements in the engineering mechanics also while you are calculating for the friction. See, all the subjects are interrelated, and when we are at the stage when we have completed many subjects, so we have to think in this way also, that we have seen somewhat this problem, this kind of problem in engineering mechanics also. If you see like friction is there like that, okay, I hope you can reconcile it. Okay, so we have this 30 degree, and what we are required to find, we are required to find the dynamic viscosity of an oil. So now if you see this kind of a question in your examination, I hope you will be able to identify this question belongs to the topic Newton's law of viscosity. Now, once you identify that it belongs to the Newton law of viscosity, so we have tau is equal to mu du by dy. Okay, so what we require? We require a velocity. Okay, we require a velocity. So it has been given that it is sliding down at a uniform velocity of 0.3 meter per second. So we have this velocity as 0.3 meter per second. So we got a velocity. And obviously this plane is being fixed. Okay, so the shear stress, so we have to find this mu. So this, very good Satyam beta, very nice. So we have this velocity, now we have this 0.3. Okay. Now remember what this gap, this is the gap between the fixed surface and the moving surface. See, things are very easy only. You require a velocity, you require a gap from which there is a velocity, okay, which is fixed or maybe which is having a zero velocity, right? So this gap, what they are saying, the thickness of the oil film is 1.5 mm. The thickness of the oil film is 1.5 mm. So this is 1.5 mm. Now here we have to be very conscious about the units. So you have placed this velocity in meter per second. So we must be placing this in meter, right? In meter. Okay, so now in this equation, if we have the shear stress, will we be able to find out? If we have the shear stress, we will be able to find out, I think, the mu. Because again, the concepts remain same. What is the concept? The concept remains same, that if we have an equation, and in this equation, if all the other variables are being known, if you have to find one variable, the rest of the variable must be known to you, right? The rest of the variables must be known to you. So we have the shear stress, and this is going to be mu du by dy. Now we have the shear stress, and this is mu. So what is okay? So we already have made this equation, right? So now we have to find the shear stress. Now how we can find the shear stress? So if we see, so this is the weight of this plate, right? This is the weight of this plate. Weight always acts in upside down. Now please remember the force we are here talking about. What is this force we are talking about? Or what here is the force we are talking about? So remember, again a very important point in which a student get confused. So this force always is parallel to what you are going to use in your Newton law of viscosity. So it should be parallel to, it should be what? It should be parallel to, it should be parallel to the direction of velocity. It should be what, beta? It should be parallel to the direction of velocity. Now, if this is the direction of velocity, in this case, we shall have the component of this W in the direction parallel to this velocity. So this should be W sine theta. W sine 30. I hope we must have done this in lot of times in engineering mechanics, that if there is an inclined surface and the angle is theta, we have this component as W cos theta and we have this W sine theta, right, Buddha? Right, Buddha? Please answer me. I hope it is fine to you. And also, if you don't want to do this way, if this is 30, this is 60, it is going to be W cos 60, right? W cos 60 means W sine 30. right? Either way you can do. So, but remember this, that while we are writing this force is equal to tau into area, this force is going to be the one which is parallel to the direction of velocity. So what we have this weight which is 300 Newton. So we can write it this way. 300 Newton is the weight, and so we have the force now tau and surface area. So they have given you the surface area because a square plate is there. So it is zero point 0.8, zero point 0.8. So surface area is 0.8 into 0.8. 0.8 into 0.8. So from here, obviously you can find the shear stress. Obviously you can find the shear stress. So what we are getting the shear stress here? What is the shear stress that we are getting from here? What is the shear stress that we are getting? So this should be W sine 30 also, na? W sine 30. W sine 30. So the weight is 300. We have to multiply sine 30 also. So, yes, Pranjali. Yes, sorry. So this is sine 30. So this is going to be 150 upon, this is going to be 88.64. So we have got the tau here. So 150 upon 0.64, 150 upon 0.64 is equal to, so what is this tau? Tau is mu du by dy. So we have mu here, the velocity is 0.3, and we have this gap 1.5 into 10 to the power minus 3. 1.5 into 10 to the power minus 3. So here we will be getting mu is equal to 1.17. I hope all of us can solve it now. Newton second per meter square. Now tell me guys if it is fine to you or not. Please answer me. Tell me if it is fine to you guys or not. Please answer me. Please answer me. Please answer me guys. Those who are not able to solve it, remember the important concepts here. Very nice. What are the important concepts here? So to solve a problem of Newton law of viscosity, we shall look for what we should do. We shall look for, we should look for what? We should look for a velocity, a gap, sometimes area, the surface area, right? Now I want you guys to solve this one, beta. Let's see if we can do this one. Let's see if we can do this one. Please go ahead. Please go ahead. Let's see if we can do it. Please go ahead, beta. Let's see if we can do it. Please try to solve this one, beta. And please do not forget to subscribe as well, beta. I'm looking for answers. I hope we can solve it, beta. Very quickly we can solve it. Please go ahead. Any answers? Remember what we require, beta. Remember what we are supposed to do. Remember velocity, what we require to solve. We require a velocity, we require a gap. Okay. We are we are requiring a velocity, we require a gap. Okay, then we can formulate the things. Please try it, beta. I'm very sure that we can do it. No problem at all. Using the same concept, please try it. I didn't receive any answer till now, beta. I'm very sure we can do it, beta. I'm very sure we can do it. Please do it, guys. We can do it, beta. Please go ahead. Any answers? Any answers? Is it that tough that none of us can do it? Is it that tough, beta? I don't think it is that tough. Is it? Okay, so we have got one answer, and that answer is not correct. It is okay. Let me see. No, my dear, this is not correct. No, Pranjali, no, beta. Is it that tough? Is it that tough? I was not expecting this at all. Any other? Anyone else? Okay, so I'll do it. Now, please understand. So, R15. So, all of you must be, whenever we see a question, always try to make a diagram out of it so that the things will be in front of you, and definitely it is going to help you solving that question. So, a 15 centimeter diameter vertical cylinder rotates concentrically inside another cylinder of diameter 15.10 centimeter. So we have a, so it is a vertical. No problem. We can make it horizontal also. It is not going to cause. So let's make it vertical. No problem. Okay. So we have a vertical cylinder. Okay, and inside it we have another cylinder which is rotating as well. Okay, so inside this cylinder we have one more cylinder. Inside this cylinder we got one more cylinder. Okay, inside the cylinder we have one more cylinder which is rotating at some velocity. So which is rotating at some velocity. So let me make it a bit larger here. So somewhat it is rotating. Now I want to ask you guys. So this is rotating, Vikram. Okay, so many of us are getting the same. Nah? I think the same mistake we are making here. Okay, let us see. Okay, so when we have this cylinder inside it and it is rotating at some velocity, now tell me one thing, whenever some circular cylinder is being rotated with some velocity, do it have surface velocity or not? Please answer me, Vida. So it have this surface velocity, yes or no? That we generally know as this r omega or pi dn by 60. Please tell me yes or no, beta. Is it fine to you guys or not? Now let's see what they have given to us. Now let's see what they have given. So they have given us RPM. Now again, remember my tip. Sometimes because we are very much habitual, we sometimes get very much habitual. Okay, Pranjali, let me check. So again, it is not correct, beta. Again, it is not correct. No problem, beta. No problem. I'll see it. Okay, we'll solve and we'll see where the mistake have happened. Okay, so we have this pi, and what is this diameter? What is this diameter? So the diameter is 15 centimeter. Do not forget to convert it into meter, and we have this RPM as 100 RPM. Okay, so sometimes what they do, they give you this RPM instead of they give by instead of giving the RPM, they may give you the RPS, that is revolution per second. So remember, when they have given you the RPS, you need not to divide it by 60. You need not to divide it by 60. So we have this velocity now here. We have this velocity now, and it is in meter per second because we have converted this diameter. We have converted this diameter. We have converted this diameter into what? Into centimeters. So when we are solving this, so what we are getting, I hope we are getting 0.7854 meter per second. Now we got the velocity. Now to find the shear stress, so what ultimately has to be found? We need to find the viscosity here. So when we are required to find the viscosity, obviously what is to be done? We shall be using this formula anyway. Yes or no? We shall be using this formula anyway, right? Right, no problem at all. Okay, we shall be using this formula anyway. Tau is equal to mu du by dy. So we got the velocity here. We got the velocity. It is 0.7854. Please check the calculation. Those who are live can help me in this. And what is this dy? This dy is the gap between the two surfaces which are having different velocities, right? So this gap. Now here, sometimes the student what is the mistake they usually make here? So they take this device from both the sides. This is okay. This is the velocity here, and this is the velocity here also, na sir? So my dear students, how many surface a cylinder have? It is having one surface only. Forget about the solid surfaces. Okay, it is having one surface. So you have to take the velocity from one of the surface. So you have to take this gap. This is the gap from one side only. Okay, from one side only. Getting my point, beta? So what is this H? No, Vikram. What is this H here? So this is given to be 15.1. Okay, so this is 15.1, my dear. This is 15.1. 0 centimeter, and this much is 15 centimeter. So what is the gap in this? So what is this H here? So H is obviously 0.10 by 2 centimeter, because the difference of 0.1 happens to be on both sides. So remember what we shall be using while using what we shall be using while applying the Newton's law of viscosity. In the rotatory case, you must take the radial clearance, not the diametrical clearance. Please remember this concept, otherwise you are going to make some mistake here. So we are going to get it in centimeters. So we have to, when we are putting it this formula, we have to convert it into meter. So we have to convert it into meter. So it must be multiplied with 10 to the power minus 2. It must be multiplied with 10 to the power minus 2. I hope it is fine to all of you. Right, beta? I hope it is fine to all of you. Okay. Now we are required to find the viscosity in poise here. Okay, we are required to find the viscosity in poise here. So obviously, what we are required to find, we have to find the shear stress now. Okay. Now, what is the other data they have given? So they have given you the torque. Now we know the torque is force into radius. Yes or no, beta? I hope this is fine to all of you. So this is 12 Newton meter. This is the force. Do remember to take care of the unit. So 7.5. The diameter is 15. So obviously the radius is 7.5. And we have to convert it into meter. before putting it into this formula, because torque what you are using here is in Newton meter, right? But it is going to be in Newton meter, so we have to change this radius into meter. So when we are changing this radius into the meter, it is going to be 7.5 by 100. Now from here we can find the force, right? From here we can find the force. Can we or can't we? We can find the force, right beta? We can obviously find the force. Yes or no? Okay. Now from where we have to find the shear stress? So we have to find the shear stress by using force into area. Now here comes the concept, the key concept. So whenever it is our tendency that whenever we see a circular shape, we are very much tempted to use the formula pi by 4 d square. So remember guys, not to use it. Now Pranjali, you have given me the correct answer. Okay, now tell me where the mistake have happened. Okay, so this is not, remember not to use pi by 4 d square, because what I'm telling you that we have to use the surface area. So surface area is what beta? Of a circular thing, of a cylindrical thing, it is pi into d into L. Okay, so this is the mistake that people do. So we can find the force from here. We can use this pi dl thing. Okay, so force you can put here pi into d by L, because F by A is what beta? Stress is F by A. So, oh, sorry. Actually, I have written it opposite. My mistake. Okay. I should write force is equal to, so we can find the force from here. So force is shear stress into area, right? Shear stress into area. Okay, or we can write the shear stress at force into area. Okay, thank you, Vikram. So this area is beta what we have to use. So whenever we have a circular surface or a cylindrical surface, we sometimes get tempted to use this formula. So don't do that, beta. Don't do that. We always have to use this one. Shear stress is force upon the surface area, beta. Force upon the surface area. So what is the surface area here? Surface area is pi into d into L. So what is this pi into d into L? So we have the diameter as 15 centimeter. Do not forget. So force we can find out, and this pi d. So do not forget to convert it into meter. What is this length? The length is given to be high. So it is given to be 25 centimeter high. So 25 centimeter high means 0.25. Okay, so from here you can get the shear stress. From here you can get the shear stress. And then this shear stress value, we can place it in this equation 1. And we can find this coefficient. We can find this mu. So you will be getting 0.864 Newton second per meter square. Understood, beta? Please answer me. Please answer me, but we have to give the answer is poise. Okay. So if 1 poise is equal to 10 to the power minus 1 Newton second per meter square. So we know it. So we can convert this Newton second per meter square. We shall convert it Newton second per meter square into poise. So what we have to do? We have to multiply it with 10. So 8.64 poise. So what shall be your final answer? It should be 8.64 points. Now, please, guys, tell me those who are live here. First of all, those who have made mistake in this. So, what is the mistake that you have made? And do you understand this concept of Newton law of viscosity completely or not? I am seeking the answer of it. Please answer me, Mita. What do you say? Please answer me. Okay, so you didn't, Vikram. Okay, you missed D. Okay, so as I said, beta, these are very silly mistakes that we sometimes do, na? So we should not do it, beta. Okay, we should avoid to do this. Getting my point? Because you see, a lot many questions are getting asked from this particular area. So remember, we shall not make any mistake in this. We shall not take any mistake in this. Is it fine, beta? Please answer, beta. Is it fine to you guys or not? Please answer, beta. Now, can you guys tell me, can you guys say that's okay, sir, we are not going to make any mistake in this kind of a question. We are not going to make any mistake in this particular kind of question. Can you guys tell me that? Give me a yes or no. Remember, we need a velocity, we need a gap. Okay. So if you make a mistake in there, then the things will not be going to be fine. Okay. But I hope I hope you won't make mistake in this again. Right, Buddha? I hope you are not going to make mistake in this again. Right? Okay, very well. Okay, very well. Very well. Okay, so we have, let's do one more question. Let us do one more question, Buddha. Okay, so I'll be giving you one gate question now. I'll be giving you one gate question now here. Okay, let us see. Okay. Okay, so this is the book screenshot. Okay, no problem. Okay, I hope we can read this question, right? I'm hoping that we can absolutely read this question. Can we please answer it? Can we please answer it? Please go ahead. Please go ahead. I'm very sure we can answer it. Please go ahead, guys. I'm very, very sure that we can do it. Please try solving it. It is a PYQ. It is a previous year question. So obviously, I'm hoping that we can do this question very well. Anjali have given me some answer in this. Okay, very well. Very nice. Now, first of all, when you guys see this question, beta, when we see this question in the examination, I am very sure that by seeing this question itself, you can recognize that this is a question of Newton law of viscosity. How to recognize that? Very good, Sumit. How to recognize that? So again, we have a velocity, we have a surface, we have a velocity, we have a gap. Okay. Okay, we have a gap, and this is what given, it is given to be mu. So ultimately, we have to apply this formula. Tau is equal to mu du by dy. Now we can see that the things are given, very good, Satyam. Things are given in terms of the forces here. Okay, because mass is given. Now, see how they confuse you. See, that is why GATE is a brilliant aptitude paper. Okay, so in this question, if you see, they have given you two mass. One mass is capital M and one is a small m. Okay, and this big block of mass capital M is being at the velocity. Now, this capital M, what is the direction of this force mg? So it should be, it is upside down. And what is the direction of this force? What is the direction of this other force? It should be a small mg. So if any student have its slightest doubt in concept of this, he is very much prone to make mistake. Okay, but what we have learned, beta, that in Newton law of viscosity, what force we must be using? Shall we be using capital M or shall we be using small m? So you must say, sir, we learned this fact that the force we need to use here must be parallel to the direction of velocity. So we have this mg, beta. We have this mg. So when we have this mg, so this is the force we got. We need to divide it by the area. Area, what we have to use? We have to use the surface area. So we have a cubic block of side L. So what is the surface area of a cube? It is a L square, right? So this is the tau we got. Okay, mu is here. This velocity, so since it is a surface, so this velocity v we are having, what is this gap? This is h. So from here we can formulate this mu. So it is coming out to be a small mgh upon mu L square. So we got the correct answer, that is C. Now can I tick mark it? Newton law of viscosity, that's the, if a question comes of it, we will take care of it, and we definitely are going to, definitely are going to give the correct answer. Okay, so I hope this is done. Okay, this is done. Now, the second important concept. So, in this is the first chapter of fluid static that we see, in which we are supposed to see the Newton's law of viscosity. Broadly, we call it as properties of fluid. Okay. The rest of the thing that we must be seeing by our own. Okay. See, we are here discussing the important concept, not all the concept. Okay. So don't leave anything, but give more strain to the important topics because they are getting more frequently asked. So the probability of them to getting repeated in the examination again is certainly a bit on the higher side, right? But don't do this. That's okay. That doesn't take it wrong way. That here we are discussing the important concept. That doesn't mean that we do not have to study the rest of the concepts. So in this chapter, what else to be studied? You must be studying the property, viscosity, the type of fluids, capillarity, surface tension, pressure difference problems, gauge pressure inside the soap bubble, inside the droplet of water, liquid jet. We must understand the concept of vapor pressure. We must solve some questions of capillarity as well. But today's session, we are not going to include that. Now, according to me, the next important topic is pressure measurement. Agreed? Yes or no? When we are using the manometers, okay, or we can say problems related to manometers. Okay, now many students are keep asking me, sir, in 2020 this manometer is removed or what? Okay, this is a somewhat uh, confusion students are having, because somewhat is labels it is being not written, but when we are writing this fluid statics, this is the integral part of the fluid statics. Also, when we reach the dynamics portion, when we are seeing the velocity measurement or this discharge measurement problems, we see the manometers or the pressure measurement being used there. So do not think in that way that the manometer is omitted from the GATE syllabus. No, it is not. You have to study it as well. So pressure measurement. So we have to talk about the pressure problems related to manometers. Okay. Now please understand this. How to solve a problem of manometer? According to me, it is very important concept. So I will give you a trick here, not a trick, but a very comfortable way of solving the problems of manometers. Okay, so I am going to give you a very easy way, or we may say that very simple way of solving a problem of manometer. Okay, so see, when you see a problem of manometer, so please show us a problem of manometer. So okay, I'll show you. Just now I'll be showing you the problem of manometer. So let's see. Let's suppose this is your problem of manometer. Okay, this is somewhat manometer look like now. This is how we see the problem. This is a very big problem. It's a very simple problem. I'll be solving it in a moment. We'll be solving a 2-3 questions here, then we'll be moving to the next topic. Okay, what I want to do, I want to cover as much as I can in the given time period. Okay, because we are also having no time. Gate is very near. Okay, so we must be pushing forward our preparation in the right direction. That is why at the Gate Academy we are doing this GATEvantage series in which we can quickly brush up the important concepts. Okay, so now I hope all of us must have observed the problems like this of the manometer. If you want to see a gate problem, I'll show you a gate problem as well. No problem. Okay, so let's see. What kind of a question do we see in this domain or this kind? Okay, so we see this kind of a questions also, na? We do see this kind of a questions, no? Sometimes manometer inverted. This is an inverted YouTube manometer. We have a simple YouTube manometer. We sometimes have the piezometer also. We have single column vertical manometer. We have inclined column vertical manometers like that. Beta. Okay. Now, how to solve a manometric problem? So, first of all, first thing what you shall do. So, while solving, change all the things, whatever you are having, whatever fluid you are having, you love the water most. Okay, you love the water most. So change all the things in terms of water. Okay, so first of all, you have to change all the things in terms of water. You must convert everything in terms of water, whether it is a pressure, whether it is column given in terms of another liquid. Okay, so we have to do one thing, we have to change all the things in terms of water. Secondly, when we are moving downwards from some point, let's suppose from A point or some point, we are moving in the downward direction, we must do the addition. Okay, if we are moving in the upward directions from some point, if we are moving from upward direction some point, we should do subtraction. We should do the subtraction. That is all. Now the question is, sir, how to convert something into water? So I hope we all are aware of this formula given by the hydrostatic law, that P is equal to rho GH. Yes or no? Yes, sir. Now for a given pressure, so see, this is how our pressure can be represented in terms of the height of column of liquid. Yes or no? Yes or no? Please answer me. And if we have tried to measure our blood pressure also, sir, we have a digital one. Forget about the digital one. If you see that the manual one, in which you will see mercury rising, if you ever get to see. Okay, but hopefully you must not be you must not come into this condition in which you have to get your blood pressure checked. Hope not. Okay, but you can have it observed for the sake of understanding. Okay, so we see the pressure in terms of head of liquid. Now for a given particular pressure, so if we are keeping this pressure constant, so we can use some liquid, let's say rho1 H1. We can use some another liquid, rho2 H2. We can represent it in some another liquid, rho3 H3, and so on. Right? Some pressure can be represented this way. Some pressure can obviously be represented in this way. Now every H will be changed. Every H will be what? Every H will be different. Every H will be different because you are changing that density. Now from here, for a given pressure, we can write like this also: rho1 H1, rho2 H2, rho3 H3, right? And if we want to write it in terms of specific gravity, if we want to write it in terms of specific gravity also, what we can do, we can write this way: S1 H1, we can write this way S2 H2, we can write this way S3 H3, where S is what? S is the specific gravity. And what we know? We know that water, the specific gravity, is nothing but one. Now the simplest thing what I should be telling you here, that let's suppose we have a column in which we have let's suppose we have this height as 2 meter. We have this height as 2 meter, and this is some oil. This is some oil. Okay, this is some oil of, let's suppose, a specific gravity 0.8. So I hope we know specific gravity is density upon density of water at 4 degrees Celsius, but when nothing is mentioned, we use it as 1000. So that means that the density of this oil is 800 kg per meter cube, right, Buddha? Density of this oil is 800 kg per meter cube. Now, I want what I'm trying to do. In this we have a oil. Now, what I'm trying to do, I want to convert it in terms of height of water. So what can be done? So what we can do? So if we say that this is for given particular pressure, this is HW is equal to S naught, and this is, let's suppose, H naught. Okay, so this is going to be 0.8, this is 2, so this is 1.6 meter. So you can represent the same pressure in terms of oil, and if you want to convert it into water, you can simply do specific gravity into height. See how simple it is. Now you see this big problem. Okay, now you see this problem. So we have some specific gravity, we have something like this, something like this. Okay, so how to do it? So what is the concept? Now please understand, very simple it is. In one go, you will be able to understand it. So we are having a point A. Let's convert it. So let's suppose the pressure at A is PA. In a Newton per meter square, usual unit of the pressure, that is Newton per meter square or Pascal. Now, as we have discussed, or we already must have known this, that this pressure can be represented in terms of any liquid. Now, I want to represent it in terms of water. So let's suppose in terms of water, it is HAW. It is HAW. Now, from hydrostatic law, I hope we are aware that when we are moving in this direction, there is no change of pressure. In a static fluid, from a particular point, when you move horizontally or in this direction that you see here, is there any change of the pressure? Do the pressure change? No, sir. It do not change. Right, beta? No, sir. It do not get changed. Okay, so it is not getting changed, beta. It is not getting changed. So from here to here, no change. So we are not have to write it. And we have reached to this point. Now moving downward. So when we move downward, we have to add something, right? Now what to add? Change everything to water. Now in this, there is a yellow liquid whose specific gravity is 0.8 and height is h1. Now how to convert it into terms of water? Just simply multiply that particular height with a specific gravity. Now where we reached? We reached to this. Just move with the liquid. Okay, we have reached to this point. Now from this point, we are moving downward. From this point, we are moving in this direction. And till this point, we are moving in this direction, right, Buddha? Like this. Like this. Now in this part, we are moving. So let's suppose this is Y. So this is also Y. Okay. Now if you see from this point, we are moving downward. So we are adding S1 Y1 because we are moving downward. Now we are moving horizontally, nothing to be written. Then we are moving upward. So from this point, when we are moving upward, we have to write minus. So in which liquid we are moving? We are moving in the liquid of S2. Here also we have moved in the liquid of S2. Here also we have moved in the liquid of S2. So we have this S2Y1. Now this is going to be cancelled out or going to be 0, right? Now what does that mean? Now what does that mean? Let me subtract, let go of everything here. Okay, okay, so now if you see, okay, so if you see this portion from which I am marking it now, so from this portion to this portion, is it of any relevance? So the answer is no, because in the same fluid, the same amount of height we are moving downward and same amount of height we are moving upward. So it has no contribution here in pressure measurement. Similarly, in this green fluid, if you see, so we again have nothing, no contribution. We are moving the same amount. This part have no contribution. In this fluid, this part has no contribution. In this fluid, this part has no contribution. Okay, so in the pressure measurement of manometers, if we are moving in the same fluid by the same distance in both the direction up and down, that is of no relevance. Now again, let's start doing this question and compiling all this concept. So first of all, change everything to water. So let's suppose the pressure in this pipe is A. So let's suppose this is HAW. Now moving in this horizontal direction, we need not to write anything. We have reached this point. Okay, now we are moving downward. Remember, when we are moving downward, we have to add. So what is to be added? S1, H1 is to be added. What is to be added, beta? S1, H1 is to be added, because when we multiply the specific gravity with the height, it is getting converted into water. Now we have reached this point. Now from here, we can directly jump to this point, because in the same fluid, upside down. Okay, same fluid upside down, so we do not have to write it. Now from this point, we are moving in upward direction. So when we move in upward direction, what is to be done? We have to subtract. And how much we are moving upward? We are moving upward by H2. So keep multiplying S to H2. Keep doing this, S into H. You are converting into water as explained. Now in this green fluid, we are moving. So from this point to this point, we can directly jump, because in the same liquid, we are moving from here. Now from this to this, we are moving downwards. So when we are moving downward, we have to add, and this is going to be S3H3, right? So we have reached to this point. Now from this point to this point, from this point to this point, we are moving in the same fluid. So we can jump from here to here. Okay. Now from here, we are moving upward in the upward direction. So when we are moving upward direction, we shall subtract, and we are moving in the liquid, that is S4, and we are moving by the height H4. Now we have reached to this point. From this point to this point, we can directly jump, and no difference will be happening. So from this point, we will be moving downward. And we are moving by the distance of H5 in the liquid S5. So this is going to be S5H5. Now from this point to this point, there is nothing to be written. And now from this point, we are moving upward, So this is S6. Now please tell me, guys, how I have written this equation. Is it clear to you guys or not? Please answer me, Vida. Please answer me up to this part. Now, as I see that this manometer is open to atmosphere, so if it is open to atmosphere, you can put it equal to 0. Now, if all these values are given to you, so in one go you can do it. Otherwise, what we do, we balance the columns. That is also an easy way, but I find this way more suitable and more easy to solve. Is it fine, Beta? Please answer me. Please answer me. Do you understand this or not? Please answer me, Vida. Do we understand this or not? Please answer me, my dear. Wonderful. Okay, wonderful. Now I want you to write it once more for me for this question. This whole pressure measurement, I have summed it here. So this is what we call as a differential manometer. So in a differential manometer, we have pipes on both the ends. Okay. Now the same way, using the same concept, you can start writing the equation. But in the end, what you have to do here, after equal to, we have placed 0. In this case, after equal to, you should be placing the pressure at this pipe B. Now please go ahead. I am very sure that we can do it. Please go ahead, Beta. No problem at all. And meanwhile, Beta, please do not forget to like and subscribe the channel, Beta. Please do like, please do subscribe the channel, beta. Please go ahead. Tell me when it is done in the live section, beta. Tell me when it is done in the live chat section, beta. Please go ahead. I'm very sure we can do it, beta. I'm very, very sure we can do it. Please go ahead, beta. Please go ahead. Any answers, beta? Any answers? Any answers, my dear? Please answer me. I am hoping to find the correct answer. I haven't received any answer. Tell me if it is written or not. I'm very sure you can do it, beta. No problem at all. Very, very sure that you can do it. Please go ahead. Very nice, Pranjali. Tell me when it is done, beta. I want all of you to attempt this. Very nice, Prasanna. Okay, so I'll do it now. So we have two pipes. So again, we can start either way from A to B. Okay. So from A, so what is our concept? We need to change everything to water. So whatever pressure is there inside this pipe, we are not at all worried about it. And we can start by writing HAW. Okay, HAW. Now from this point to this point, we need not to write anything because what? Because we are not changing in the horizontal direction the pressure is not getting changed. Now in the downward direction, so we can add it up, change everything to water. So H1S1, from here to here we can directly jump, because if in the same fluid we are moving by the same distance, so we shall not be writing anything. From here to here we can directly move up. Now from this point we are moving upwards, so we are having S2H2, and we are moving upwards, so it is the negative direction. Now from this point to this point we can directly jump to, again we are moving downwards, so plus S3H3. Now from this to this, now from this to this, we are having, we can directly jump. Now from this point, we are moving upwards. So minus S4H4. Now from this point to this point, we can directly jump to, now from this point, we are moving downwards. So S5H5. Now from this point to this point, we can directly jump to, now we are moving upwards. So S6, S6, and then we are moving further upwards. So minus S7, S7, and then we have reached to this point. Now we are moving horizontally, nothing to be written, and once we reach this B point, we can put it equal to HBW. So this is what we call as manometric equation in this case. What do we call it? We call it manometric equation in this case. Now please tell me guys if it is fine to you guys or not. Please answer me, Vida. Do you understand it or not? Please answer me, Vida. Do we understand it or not? Please tell me, Vida. Please tell me, Vida. Will you be able to write the manometric equation correctly now? Please answer me, Vida. Will we be able to write the manometric equation correctly or not? Please answer me, Vida. Very nice. Now I have one more question for you. Now let's suppose in this case, we have solved. Now let's suppose in this case we have solved. Let's suppose in this case we have solved and we have got. So if all this value of S1, H1, everything is given to you, I hope at some stage we'll be finding it. So let's suppose we have found it equal to 2 meter. Okay, let's suppose we have found it equal to 2 meter, and final answer we have to give in Newton per meter square. Now my simple question to you is, so obviously we have find this HAW. So you can say that, sir, I can convert it this liquid column in terms of the Newton per meter square unit by using this formula. PA is equal to rho GH. I think it is a yes from your side. Yes or no? Definitely we can do it. Definitely, I suppose we can do it. So PA is equal to rho GH. Now my question to you is, so if the fluid flowing here having the specific gravity 0.8, now the question is beta. Now the question is beta. Now the question is, shall we use A 800 in for this row, or shall we use 1000 here? Option A or B? See, we have found the column, we have found the pressure in terms of head of liquid. Okay, head of liquid. So obviously, when we need to convert it into Newton per meter square, when we shall convert it into Newton per meter square, we shall be putting some density. So shall we be using 800 or shall we be using 1000? Please answer me, beta. What shall we be using? What we shall use here, beta? Please answer me. What we shall use? Please tell me, beta. What should we be using here? Please respond. What do you think? Shall we be using 800 or shall we be using 1000? Please answer me, beta. Please answer me, guys. I am waiting for your responses, beta. Okay, Pranjali have answered something. What about the rest of you? Vikram, Gayatri, Satyam, Prasanna. What about you guys? Shall we be using 800 or shall we be using 1000? So remember, guys, sometimes we get this confusion. Sometimes we get confusion here. This we shall be using 800. So remember, we have converted it into water. Remember this, it is head in terms of what? In terms of water. So obviously to convert it back into, the pressure, that is Newton per meter square, we shall not be using 800, we shall always be using 1000. Now remember this point, beta. If you are using this method for solving your question, in the last, when you are supposed to change your findings in Pascal or Newton per meter square, you must be multiplying the GH with your density, which is 1000. Now, please answer me if it is fine to you guys or not. Okay. Now, let's do one question. Okay. Please try this one, beta. Please try this one. Let us see if we can do it or not. Please go ahead. Please go ahead. So this distance is given to be 80 meter. Beta. This is your 80 meter, right? This much distance. Please go ahead. Let us see if we can do it or not. Pranjali, any kind of manometer you can apply it. Any kind of manometer. Okay? Whether it is an inverted, single column, vertical column, micro manometer, anything you can apply it. Okay? Okay? Please go ahead, guys. Okay, so I think this image is not very clear. Just one moment, huh? I'll be changing this image. Just 1 second. Just 1 second, huh? Just read the question, beta. So actually, this is 80 mm, right? This is 80 mm. Okay, I'm just doing it again. This is 80 mm. I hope now you can do it. Please go ahead. Please go ahead. I'm very sure that you can solve it. Please try to solve it, beta. Please try to solve it. What about the rest of you, beta? What about the rest of you? Please solve it in the same way. Well, any kind of a manometer, you can do it. Okay, so I'll do it. So when you see this question in your examination, if you at all you see this kind of a question, so I hope it is very, very easy to recognize that sir, this is the question of manometer. Now manometer, if it is a question of manometer, what we should do, we should be changing everything to water. If we are moving upwards, we should subtract. If we are moving downward, we must add, right? So an inverted U-tube manometer is used to measure, is used to measure the pressure difference between two pipes A and B. So we have two pipes, so it is a differential kind of manometer. So between A and B, as shown in the figure, pipe A is carrying oil of a specific gravity 0.8 and pipe B is carrying water. So we have in one pipe we have the oil, in another pipe we have the water. We have the water and the densities are given. So we can start with A or we can start with B. Okay. So pressure difference between A and B, it is being asked. So let's start with the A. Okay. Let's start with this A point. Okay, beta. So this is our A point. So what is the concept? Convert everything to water. We are not interested at all what is inside the pipe. Convert it into water, right? This way. Now from this point we are moving horizontally, nothing to be written. Okay, nothing to be written. Okay. Now from this point we are moving upward. So we must subtract how much we are moving. We are moving by the distance of 200 mm, that is 0.2 meter. And we are moving in this oil, which is having a specific gravity of 0.8. Where we reach this point. Now from this point to this point, we are moving in air. So again, we are moving upward direction. So we are moving. So we shall subtract. So this is minus 0.08. No, Pranjali. It is minus 0.08. It is minus 0.08. It is minus 0.08, right? It is minus 0.08, right, Buddha? The distance and the density of the air is given to be 1.16. So how to find the specific gravity from density of a fluid? We should divide it by the density of water, 1000. Now from this point to this point, now from here to here, we are moving by the same direction, by the same distance, up and down in air only. So this is having no meaning. So from here, we can directly jump to this point. Now in this, we are moving downward. So when we are moving downward, beta, we shall add. When we are moving downward, we shall add. So we are moving by what distance? We are moving by the distance in water to 380 mm. We reach this point. So 0.380 and we are moving in water. So it is need not to multiply with 1 because it is already water. Okay, but we'll follow the process. We'll be multiplying the height with the specific gravity. So this is going to be 1. Now from here we are moving horizontally. So nothing to be right, nothing to be written. Now we have reached this point B. So we can equate and we can use HBW. We can use HBW. So from here, what we are getting to find? What we are finding from here? Can you guys tell me, beta, what we are finding from here? What are we getting from here, beta? What are we getting from here? Are we getting something or not, beta? Are we getting something or not? Definitely, I hope we are getting something. What are we getting here? Can somebody please answer me, beta, what we are getting here? Can somebody please calculate and tell me, beta, what we are getting here? Anyone? When we are calculating it, what we are getting, beta? Please someone answer me. So are we getting from here? So are we getting HAW minus HBW from here? HAW minus HBW is point minus of 0.219 meter. So if we solve this equation, I hope we are getting this. If we solve this equation, we are getting this. Yes or no, beta? Yes or no, beta? Please answer me. Are you getting this or not? When we are solving this equation, we are getting this. Right, beta? Agreed? Agreed? So I hope yes. So this is minus 2.19 meter. But we need to give answer in kilopascal. Now, don't make mistake in the unit. First of all, it is a numerical data question. So sometimes people think, sir, we can ignore this minus. No, it is clearly written that we have to give the pressure difference between A and B. So if you ignore this minus sign, your answer is going to be incorrect. Okay, so how to convert it? How to convert it? So what is to be multiplied? 1000. No matter what is inside the pipe. In this method, in final, when you are converting it into Newton per meter square, you have to, or Pascal, you have to multiply it with 1000. That is the density of water into minus 0.219 minus 0.219 Newton per meter square. Newton per meter square. So from here, what we are getting, beta. So when we solve it, we will be getting minus 2.2199 something Pascal. Okay, so this is HAW. HA, that is, we have now converted it into pressure, so we can write it as PA minus PB. Now this is uh, minus 2199, so we need to answer in kilopascal. So it is somewhere minus 2.19 kilopascal. So what is the answer to this question? The answer should be minus 2.19 kilopascal. Now please tell me if it is fine or not. Please answer me, beta, if it is fine or not. I hope it is fine to all of you, beta. Now I want you to do this question. This is a GATE civil engineering question. I like this question a lot. Okay, please go ahead. Let's see if we can do it or not. Please read the question properly and then try to solve it. Please read the question properly and then try to solve it. I hope we can do it, beta. I hope we can do it. So I think again some mistake in the just 1 minute. Please go ahead, solve this question, beta. Let us see if we can do it or not. So just change this like this. Okay, so this is actually, so the same fluid is there. It is like this, beta. This is like this. Please go ahead, beta. Please solve this question. Now this is the figure, correct figure. Please go ahead. And also, actually, this is 3 meter. This much is 3 meter. Please go ahead now. So if you have any doubt, you can use this figure, no problem. Okay. Same from here also. I think this is clear now. Just let go of it. Don't be confused. Please read the question and then do it. Any answer, beta? Any answer, my dear? I hope, guys, we can do it, beta. Any answer? As I said, we can do any question by this concept. No problem. Very nice, Prasanna Beda. Very nice. Correct answer you have given to me. Very good. Very good. So let's read this question. Let us read this question. What is this question asking to us? So two pipelines, one is carrying oil and the other is carrying water, are connected to the manometer as shown in the figure. By what amount the pressure in the water pipe shall be increased so that the mercury level in both the limbs of the manometer become equal? Okay, so what they want us to do, so they want us to increase the pressure. They want us to increase the pressure here in such a way that the pressure becomes same. Okay, so let's do like this. So how much the pressure shall increase? So in this condition, what is the pressure difference? Let's try to evaluate that first. Let's try to evaluate that first. Okay, so in this condition, change everything to water. So let's write it as HOW. We are moving downward, so we shall add. So I started here. I started from here. Okay, so HAW, so we are moving downward, so we must add. So plus 3 into what is the specific gravity of oil. So they have given the density as 900, so we shall multiply it with zero point 0.9. Now we reach this point. Now from this point to this point we are moving in the same, that is mercury, need not to write anything. Then we are moving upwards, so that is 20 centimeter into zero point 0.2, and the density of mercury is given to be 13,550. Now converting it into the specific gravity. Now converting it into the specific gravity. So this specific gravity is 13.55. Okay. So we reach this point. Now we are moving upwards in water by the distance of 1.5. So when we are moving upward, we shall subtract. So it is minus 1.5 and we are moving in water. So it is 1 is equal to, let's call this point as B. Okay, so we are getting HBW. Now from here we can find HOW minus HBW. So initially the difference between both, so when we calculate it, I think we are getting 1.51 meter. Are we getting that or not? Please answer me. I hope all of us are getting the same. So we are getting 1.51 meter. Now, is it fine up to this point? We have done nothing new. We have done nothing new. Please answer me, Vida. Those who are live, please respond to me on this. Is it fine up to this point? Please answer me. Any issue? Very nice. Now, what they are asking us to do, read the question. So, by what amount the pressure in water pipe should be increased so that the mercury level in both the limbs becomes equal? Now, first of all, they are asking you to increase the pressure in the water. That means that they want us to keep the pressure in the oil pipeline same to the previous case. Okay. So, when we are increasing the pressure of water, obviously this mercury level will be going down, and it should come down by the distance of 10 centimeter. Only then the level will be same here. Say yes or no, beta. And this should also be 10 centimeter. Please answer me. Please answer me. Then only the liquid will be same. Na? What they are asking us, that the mercury level in both the limbs shall be same. Now that means that it should come down from the right limb. The mercury level should come down in the right limb by 10 centimeter and it should rise by 10 centimeter in the left limb. Right, Buddha? Right, Buddha? Now here the whole question has changed now. Now let's suppose this is your mercury now. This is your new level of mercury. This should be like this. Okay. Now we do not have the mercury here. No more mercury in this region. Okay. No more mercury in the region. Now, though no more mercury in the region, I am marking by yellow. Will there be any liquid here? No, no mercury anymore here. So what happens here? Now here only we have water, because now this water will come down to this region. Now we can write the manometric equation again. Okay, so again what we say, so this is same as the previous one. The pressure inside the oil is not changed, so we can write it HOW. Now we are moving downward. Now since it is up by the 10 centimeter point, now we can do what? Now we can do what, beta? We can do what? So it is going to be 3 minus zero point 0.1. Previously it was 3. Now 0.1 can be subtracted from here. And we are moving in oil of specific gravity what? 900. So it is 0.9, beta. Now we have reached this point. Okay, we have reached this point. Now from this point to this point, mercury is there, and it is of the same downward distance and the same upward distance, so nothing to be written. Now from this point we are moving upward, so we must subtract, and we are moving by, previously it was 1.5, now zero point 0.1 shall be added here, and we are moving in water, then we are reaching new HBW. Now the pressure must have changed, so let's call it HBW dash. Now please answer me if it is clear or not. Please answer me. Or we can call it HBW1, whatever we want. Please answer me, Vida, if it is fine or not. Please answer me. Now, is it clear up to this point or not? Please answer me, Vida. Please answer me if it is clear up to this point or not. In the new condition, I have again applied the same way or same approach and same manometric equation. Okay. Okay. Now from here, the new difference what we, so this is the equation one. Now from it, when we make the changes, we are getting HOW minus HBW1. So we are getting, we can calculate it, and what we are getting, I hope we are getting this as minus 1.01 meter. Are we getting it or not? Let's call it equation number 2. Just by solving this equation, you will be getting the same thing. Okay. You will be getting the same thing. Right or wrong, beta? Right or wrong? I think you will be getting the same thing. Yes or no? Yes or no, beta? Please answer me. Please answer me. Yes or no, Baba? Yes, only I hope. So now what they are asking you that by what amount the pressure in the water pipe should be increased so that the mercury level in both the limbs of the manometer become equal. So how much it should be increased, beta? How much it should be increased? So if I subtract these two equations, so HBW1, can we write this way? HB, so let's subtract equation number 1 and equation number 2. So we can write this way now. HBW1 is equal to HBW. So adding these two, 2.52. Yes or no? Please answer me, madam. Please answer me. Simply subtracting them. Simply subtracting them. So if I subtract equation 2 from equation 1, or if we do equation 2 minus equation 1, what we are getting? HBW will be cancelled out, so we will be getting minus HBW1. We will be getting minus HBW1, and this will become minus minus plus HBW, and this is minus 1.01, minus 1.01, minus 1.51. So we will be getting minus 2.52, minus 2.52. So we can shift it there, and HBW1 will become, so from here we can, this is going to be like this. Yes or no? From here we can write it here. Now, how much the pressure should be increased? So the pressure should be increased by this amount. This must be the increase of the pressure. Yes or no, beta? They are asking you now how much the pressure should be increased. So the pressure should be to have the liquid mercury level same in both limbs. The pressure should increase by, 2.52 meter of water, right? Because everything you have converted into water. Now we can convert this change. So let's suppose this is delta P. So what we can do, we can multiply it with 1000 and we can multiply it with 9.81. Always in this method, we have to do it with the density of the water. So when we do it, we'll be getting 24.7 kilopascal. So the answer to this question is 24.7 kilopascal. Now, please guys tell me if it is fine to you or not. Please answer me, beta. Please answer me. Please answer me, beta. Any issue in this, beta? Did we understand it or not? Please answer me, beta. Do we understand it or not? Please answer me, guys. Did we understood it or not? Please answer me, beta. Acha. Pranjali, I hope you understood the concept now. Now, can you guys say that, sir, now if a question of manometer comes to us, we will be able to answer it? Please say yes or no, beta. If a question of manometer is asked to you now, will you be able to answer it? Confident? Yes or no, beta? So let's do one more question and let's do it, beta. Chal. I'm hopeful that now we can solve the questions correctly. So please go for it. And I'm very sure that we can do it. Please go ahead. Gayatri, equation 2 is to be repeated. Okay, very well. Okay. So, okay, let me do it again then. Okay. So, Gayatri, beta, let me make this figure like this. Now, please tell me, beta, we have this problem. Give me a yes or no on this. This is somewhat your manometer, right, beta? This is somewhat your manometer, right, beta? Now, please tell me. So, we have some oil here, and this is the level of mercury. Just let's just focus about the mercury. Okay, this is the level of mercury. Agreed or not? Please answer me, beta. Please answer me. Which is 20 centimeter? Please answer me, beta. Yes or no, Gayatri? This is the mercury now. Okay. Now let me make it here again. This is the first case in which we have written the first equation, and this is second case in which the level of mercury is supposed to be same in both the limbs. Same question, same condition. Now, what is to be done here, beta? What is to be done here? We have to have the mercury levels same in both the limbs just by increasing the pressure of water. Now, when we are increasing the pressure here, beta, this side will go down. Say yes or no, beta. This side will go down. Now, if this side is going down, obviously by the law of conservation of mass, this side left limb should go up. So when you start increasing pressure here, what is happening? This is moving downward and this side will move upward, and this phenomena must be stopped. This phenomena must be stopped only when they reach the same level. When they reach the same level. So in the second case, this should be the case that when they reach the same level, you must be stopping you must be stopping to increase the pressure. So they reach the same level. So they, when they are reaching the same level, do you understand this? That this should go 10 centimeter down and this should go 10 centimeter up, right? So now if it is going 10 centimeter down, so here in this whole region now we have water only. Yes or no? Right? And in this region we have oil only, right? So this side 10 centimeter, it went up. Now previously it was 3 meter from this point to this point. Previously it was 3 meter from this point to this point. Now it went 10 centimeter up. So from here to here, it now remains how much? It remains 2.1, 2.9 centimeter, 2.9 meter. Yes or no? Please answer me. 3 minus zero point 0.1, that is 2.9. Now similarly, this water level moved down by 10 centimeters. So this bit previously it was from this point to this point, it was 1.5. Now this 10 centimeter when added to it, it will become 1.6 meter. Now, beta, do you understand the second arrangement and how it happened? Please tell me a yes or no on this. Do you understand this, how it happened? This second case, this second arrangement. Please answer me. This second arrangement, how it took place. Please answer me, beta. Right? I hope yes. So just we have to write the manometer equation for this. So let's start from here again. So this is going to be HOW. So we are moving downward. What to do when we are moving downward? We must add, and we are moving in oil of a specific gravity 0.9. So we have to multiply 0.9. Now from this point to this point, we are in the same liquid. We are moving by the same distance downward and upward. So this much portion have no meaning as we have understood. So we from here, we can directly jump to this point. Now from this point, we are moving upwards. From this point, we are actually moving upwards. So we must subtract, or we can write plus 0, then minus, we can subtract. So we are moving by the distance of 1.6 upward, and we are moving in water, and then we are reaching to HBW. Now obviously this pressure is now changed. If initial pressure was HBW here, now the pressure has changed to HBW1, right? So this is your second equation. Now when you solve it, you will be getting this equation. Now from these two equations, you can obviously find that how much HBW1 is greater than, how much HBW1 is greater than, how much HBW1 is greater than HBW. And it is greater, as we can see in this final equation, it is greater by 2.52. Then we have converted it into Pascal, and then we had the final answer. Now please tell me guys, is Gayatri, is it is clear or not? Please answer me. Now can we try this question, Beta? Last question for this session. I hope you guys enjoyed the session and you find it useful. Okay, you can give us the feedback of yours, how you liked it or not liked it. Okay, and if you liked it, with us, please do not forget to subscribe, do not forget to share. Please share it with your friends also. So this GATEvantage series, in this session, we have spoken about the fluid statics important concept. We have spoken about the Newton's law of viscosity. We have spoken about the pressure measurement. Now, in the next session, we will be talking about the kinematics and dynamics, both. Okay, important concepts of kinematics and dynamics. In the next session, we will be trying to talk to some extent about those topics. Okay, okay. So how to solve this question again, beta? I am waiting for your answer. Thank you, Gayatri. Do not forget to like and subscribe also. Last question for the day. I am hoping the correct answer from all of you. Please go ahead. Very simply, we can do it. Right, Pranjali. Very nice, beta. Very nice, beta. Okay. So we can start doing by from A. So let's convert it into water. Okay. So we are moving upwards in water. So what is this distance? We are moving upward by 1 meter. So we reach this point. Then we are reaching upward by zero point 0.6. So when we reach upward by, so from here to here, it is needless to write because we are moving in the same water liquid. So if you write, you will have to write it back, no worries. So -1 to 1, we reach this point. Now from here to here, again, we do not have to write anything. Again, we do not have to write anything because we are moving in the same fluid, that is mercury. Now from this point, we are moving upward and we are moving upward by the distance 0.6 and we are moving in mercury. So for mercury, if nothing is mentioned, we can suitably use 13.6. Now we reach this point. Now from this point to this point, we need not to write anything because we are moving in the same fluid. And from this point, we are moving downwards. So this is 1.6 meter. This is 1.6 meter and we are moving again in water. This is equal to HBW. This is going to be equal to HBW. So from here, we can solve this equation. And when we solve it, we'll be getting HAW minus HBW. And it is going to be equal to 7.56 meter. Then we can convert it into the pressure and it will be PA minus PB. So 7.56 into 1000 into 9.81 into 9.81. So when you do it, you will be getting 74.16 kilopascal. So from here you will be getting the pascal. Then I'm very sure that you can convert it in kilopascal. So guys, okay, in today's session we have spoken about the Newton's law of viscosity. In today's session we have spoken about the Newton's law of viscosity, as well as we have talked about, as well as beta we have spoken about this new pressure measurement. Okay, so guys, I hope you have liked this session. I hope that you found this session useful for you. So please do not forget to like and subscribe and share with your friends. And we are going to meet in the next session that is going to happen tomorrow, same timing. And in that session, we'll be talking about the important concepts of the kinematics and dynamics. So this GATEvantage series is very, very useful for the students, the GATE aspirants, and we at the GATE Academy are trying to help you as much as we can in our capacity. Okay, so requesting you to subscribe the channel, and with this, thank you very much. Do leave your comments, do subscribe, and we'll see you in the next session. Thank you very much.